If you want to do great on the MCAT, make sure you know this topic well.
An object with 15 grams mass is immersed in benzene and suffers an apparent loss of mass of 5 grams. What is the approximate specific gravity of the object? So first of all, we have to understand that this is an application of Archimedes' principle, which is basically saying that the buoyant force that is exerted by a fluid on an object that is immersed in that fluid, okay, is equal to the weight of the fluid that is displaced by that object. And what we can figure out from that is, since if you have an object in like a fluid, let's say it's in a container like this, there's some water or something, and you have an object here and it's floating, there's two forces on it. There's the gravitational force, which is its actual weight, and then there's also a force pushing it up, which is the buoyant force. And so its measured weight when it's in the benzene is actually going to be simply weight is equal to its actual weight, which is mg, okay, minus the buoyant force. All right. Now, what we can say here is that since it actually weighs 15 grams, the mass of it is 15 grams, and there's an apparent loss of 5 grams, okay, that means that it appears to weigh 10 grams, okay, in the water. And so what we can say is, since the weight is actually mg, we can say that in the water it would be 10g, and then in actuality it's 15g, and then we're subtracting the buoyant force. If we solve for the buoyant force, this is going to be equal to, we bring it to the other side, we subtract 10, it's going to be equal to 5g. Now, what is the buoyant force? Well, the buoyant force can actually be described as the density of the fluid. So in this case, it's benzene B, okay, multiplied by the volume that's displaced, okay, volume displaced, multiplied by g. So that's all equal to 5g. Well, if we compare that to the actual weight of the object, 15g, that can also be expressed in the same way, where we can say that the density of the object multiplied by the volume displaced multiplied by the gravity is 15g, okay? So what we can see here is that the volume, obviously the volume displaced has to equal the volume of the object, okay, and then g's cancel, right? And so what we can say is we can take a ratio, right? Or rather what we can say is that the difference in the numbers here is actually due to a difference in density, okay? Where there's a 3-to-1 difference, right? If we divide these, ultimately, it's 15-to-5, which is a 3-to-1 difference in object density to the benzene density. So the object has to be 3 times denser, okay, than benzene. Now, how does this relate to specific gravity? Well, specific gravity is simply the ratio of that material's density to some sort of reference density. And that's usually the density of water, which is simply 1. So if the specific gravity of benzene is 1, that's going to be the density of benzene over the density of H2O, right? Which is simply going to be, the density of H2O is going to be 1, right? So we know this is equal to 0.7, right? And so if we solve for, since this is equal to 1, then the density of benzene has to also be 0.7, okay? And so we can say that if we know that there's that the object here is 3 times denser than benzene, okay, and the specific gravity of benzene is 0.7, then the specific gravity of the object is going to be 3 times 0.7, which is going to be 2.1, and C is the right answer.